see my screen?
Not
or,
yet.
Is this cool?
Not showing. Thank you.
Yeah, great. Hi, everyone. I am glad to give my talk on is automatically transcribed data reliable enough for expressive piano performance research. So my name is Huan, and I'm a first-year PhD student in AI and music program in QMUL. And this talk is an overview and preliminary investigation on my research direction, which resides in the broad topic of understanding expressive piano performance and model it with computational methods. Understanding the process where pianists take a written piece of music and transform it with artistic intention has fascinated us in many aspects, and it also has practical applications like education and entertainment. And common task in this area involves performance analysis, assessment, and rendering. And in the past, methodologies have been focused in understanding and modeling performance with domain knowledge and statistical methods. And in recent years, there has been increasing attempts to fit the performance tasks under certain deep learning frameworks. And however, we come to this awareness that data has been a bottleneck for expressive piano performance research, especially in the age of deep learning. The chart shows major data sets currently used by expressive piano performance research, and most of them comes in audio or MIDI format. The main limitation of them are size and variety in style and performer, where we have insufficient data to search for the commonality and difference in the performance of the same piece, as well as generalizing performance patterns across various music styles. On the other hand, expressive data from raw audio are hard to analyze in terms of exact timing, and piano performance research benefits the most from piano roll-like discrete events where key actions are recorded. Thus, we come to this idea of generating a batch of expressive MIDI through a neural network-based automatic music transcription system today. Meanwhile, you can view the transcription can be thought as a pre-processing pipeline that gives us annotations on note-level attributes, such as onsets, velocities, durations, and so on. Ideally, with a reliable transcription pipeline, we can generate unlimited expressive MIDI data from existing recordings. But before that, measurements are needed in justifying the reliability of such transcribed data. In terms of precision, the state-of-the-art model of transcription reported an onset accuracy of 96.72, but this was actually conditioned on the accuracy tolerance of 50 milliseconds. And given that the training and testing data from Mistral dataset already has a quantization of 3 milliseconds. Another limitation resides in the inductive bias of the model, where different acoustic conditions, such as live recordings or piano timbre, may affect the transcription results. Thus, we propose a set of measurements to verify the reliability of transcription data. In terms of objective evaluation, there are several analyses that we can perform. The first one being alignment and error detection using the symbolic alignment algorithm referenced here, where we aim to discover common errors of the transcriptions by aligning transcribed expressive MIDI with music XML score, as well as with ground truth MIDI from Mistral dataset. Another test is to verify with perceptual annotations, such as the beat estimate of Mazurka BL dataset, which we will describe more in the next slide. Meanwhile, different models shall be compared, and we can also plan to perform iterative transcription, where deviations would follow a cascade of render, transcribe, and re-render pipeline. On the other hand, we would also run subjective listening tests in rendering the transcriptions in reproducible piano or virtual instrument, where listeners are going to report the faithfulness in the reproduction of music. We demonstrate two figures of statistics where we compare the note level transcription results with the beat estimates from the Mazurka BL dataset. In this case, we search for the onset timestamp of transcribed events on Mazurka score beats and then compare with the annotations. Several observations include that in terms of beat timestamp, 50% of the beats are within plus and minus 30 milliseconds of the perceptual beat estimation. And in terms of dynamics, we can see the MIDI velocity highly correlates with the perceptual loudness of song provided by Mazurka dataset, but not as sensitive in extreme dynamics of extreme piano and forte. And finally, we want to highlight aspects to consider in the immediate future. A transcribed expressive piano performance dataset will be generated with an estimate of processing 100 most important works in keyboard history with at least 15 performances each. The next step would be performance analysis, where we aim to disentangle score and performance expression using variational autoencoders. Of course, there remains much to be done in order to further understand expressive performance, and we welcome all kinds of interest in collaborating and to advance the state of the art. And that's all of my talk. Thank you.